5, 3. Ooh. Inequalities in one triangle. I can fix that later. Sorry. Is it good though?
See?
I know. Good job. Alright, and we're going to need 3 colored pencils today as we work. I'm going to use purple, orange, and green. And you're going to need a glue stick at some point, so if you want to take those out, you can. I'm going to use orange, green, and purple. Whoa. So all sorts of not even working. Alright, so first off, we are going to talk about inequalities, because in order to talk about inequalities in a triangle, we need to know what is an inequality.
We're going to throw back here to algebra a little bit. When you see that word inequality, what word should be in the middle? Equal or equality. What does that in mean when we add it to the end? Not. So today we're talking about things that are not equal. What are the signs you remember that we can use to show something that is not equal? Oh, we might show that equal sign with a line through it when we're saying like not equal to something else. Good. What else? What if I want to compare two numbers? Like I want to talk about 5 and 3.
5 is...
How does 5 compare to 3? I might use less than or greater than, yeah.
Which one is this one? Good, less than. So we would say 5 is less than... I was going to say 3, but that wouldn't be right. What is 5 less than?
8.
Good. It's just real loud out here. Okay, so that's our less than sign.
And then what's the opposite of less than? Greater than. So let's use that same starter. 5 is greater than what? 4.
Alright, so we have our comparison property of inequalities, which just tells us when we compare two numbers, there's always 3 options. Excuse me, just choked on my spit. Yeah. No. Maybe. It's fine. I'll be okay. Alright, so if I have 2 numbers and I'm going to compare them. Okay, what's one option when I compare 2 numbers, A and B? How might A relate to B? If you picked any 2 numbers in the world, what's one of the options? A is less than B. What's a different option? Somebody said it. A is greater than B. So if I pick any 2 numbers in the world, one option is that one number is smaller than the other. One might be bigger than the other. Or what's our last option? What? They might be the same. Okay, so anytime we take any 2 numbers, we have those 3 options. Okay? Alright, our last property here before we go on to some theorems. We kind of have a lot of vocab today. We only have 4 examples, but they're pretty short examples. Is our transitive property. Okay, before, with transitive property, we said if A equals B and B equals C, then what? A equals C, yeah. Okay, so for our transitive property before, we did A equals B and B equals C. Now we know A is equal to C. We know they're all the same. If I say Ava has the same cell phone as Damien, and Damien has the same cell phone as Sophian, what do I know about Sophian and Ava? They have the same cell phone. Everything's the same. Okay? But now with inequalities, this is our now. What are we going to do now with it? If we know A is less than B and B is less than C. Okay? If we know that Miss Morel is shorter than Ahmed, and Ahmed is shorter than Hakeem, what do you know about me and Hakeem? What? Yeah, okay. I'm shorter than Ahmed. We already said that. Ahmed, stand up. Okay, stand up. Okay, is Ahmed taller than me? Okay, I'm shorter than Ahmed. Ahmed, go stand by Hakeem. Hakeem, sit down. Hakeem, stand up. Is Ahmed shorter than Hakeem?
Yes.
Okay, without me moving and without Hakeem moving, what do you know about me and Hakeem?
We're the same height.
What? You know we're the same height? Who's taller?
You. No, he's still taller.
You guys.
I still look like a midget.
Yes. If I'm shorter than Ahmed and Ahmed is shorter than Hakeem, then you guys know I'm shorter than Hakeem. Okay, let's talk about age then. Okay? If Miss Sawyer is older than me,
How do you know when I say our age?
and I'm older than Miss Acock,
It's okay. I'm way older.
without knowing our actual ages, who do you know between the 3 is going to be the oldest?
Who'd you say? You.
Whoa. I'm older than Miss Morel. Miss Morel is older than Miss Acock.
Who's the
Who
oldest?
is the oldest?
Her.
Right.
Who do we know is the youngest?
You. No. Wait, her. Miss Acock.
Miss Acock, yeah. Miss Acock teaches next to us. Okay, so if I know A is less than B and B is less than C, then A is less than C. No, she teaches right next door.
Is her husband teacher?
Oh, her dad.
Her dad?
Yeah.
Who's her?
Alright. That's our transitive property. If A is less than B and B is less than C, then A is less than C. Alright. We're going to throw back to the exterior angle theorem real quick. This we learned back in chapter 4. And this is what we kind of just talked about now. So if I have a triangle and one side is extended, meaning it goes longer and goes past that vertex, I label these as 1, 2, 3, and 4. When I add angle 1 with angle 2, that's going to automatically give me angle 4. We could go through the whole like minus 180 and then take that minus 180, but that's always going to be the case that 1 and 2 are going to add up to 4. So I'm going to write that very specifically here. Measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. And I know I wrote that kind of goofy. Okay, so measure of angle 2, measure of angle 1. When I make these boxes, I know when I put those boxes together, it's going to make all of angle 4. So I'm going to make that box just as wide as the other ones. Because the third angle, we just know that that would be what it is if we subtract 180. So that's the 1 and 2 are called our remote interior angles. We don't want that consecutive one, the one right next to it. We want our remote interior angles. All right, so because of this, this brings us to our exterior angle inequality theorem. Okay, exterior angle inequality theorem, and that tells us that if 1 and 2 add up to 4, how is 1 going to compare to 4? Yeah, if 1 and 2 together make 4, and I take away the 2, Shukri, go to prayer. Shukri, go to prayer. Go, 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 go. If I know that 1 and 2 together make 4, how does 1 and 4 compare? Which one is going to be bigger? 4. Why is 4 going to be bigger? What? Because it's on the outside, and because I know for angle 1, I have to add angle 2 to get 4. If I take away that angle 2, it's not as big. What about if I take away angle 1? Is angle 2 bigger than angle 4 without the 1? No. No, because it needs the 1. These two have to be together to make the 4. If you take 1 away, it's always going to be smaller. Okay? So measure of angle 1 is going to be less than the measure of angle 4. And the measure of angle 2 is less than the measure of angle 4. And I'm going to color code those again just the same we did up here. So the outside angle is going to be bigger than either of the inside angles. Because those two together have to have each other in order to make it bigger than, or to have it equal to 4. So as soon as we take 1 away, they're smaller. Alright, this is your only student today. We're going to do 2 problems with this, and then there's one other theorem that sounds really complicated, but it actually makes things So much easier. Alright, try and glue it in so that its numbers are facing the right way. If you glue it in upside down, that's okay. It's really not that big of a deal. Alright, I think I have enough space to glue it in down here, so I'm going to. You want the J and K to be going across the top. If yours don't go across the top, that's okay. What? No, you have to lick that one to make it work.
Don't do it.
Yeah. Well, now you're just throwing things.
I know, I'm sorry. Can you grab another one?
I ordered more.
Did you?
I did. Maybe that will come. Okay, so for this first one, go ahead and glue that in. If you haven't glued it in yet, glue it in. We're going to have two problems with this. Our first problem, we want angles less than the measure of angle 7. So our first thing to do is to locate angle 7 and say, is it on the inside or is it on the outside? It's on the outside. And I want to know it's on the outside of what triangle? So if I look at the triangle, it for sure has L, right? And it's got to go from L to K. And then where does the rest of that triangle go so that 7 is on the outside? To M? And then back down to L. Okay, is 7 on an exterior angle of that triangle? So I know that that's bigger than the remote interior angles. So what are the two inside angles that aren't right next to the 7? 5 and what? 5 and 4. Is there another triangle that I could have drawn other than triangle KML? I know for sure for this angle 7, it has to go past that L. But where else does it have to go? Past the M. Does it have to stop at M for angle 7? No, it could go all the way to J. So now, for angle 7 to be bigger, what are the interior angles of this triangle? And they have to be in the corners of the triangle. So what's one of the interior angles in the corner of the triangle? What? 1. Okay, is there any other angles that are on the inside? What are you looking for, these? Oh, I think that it's in the drawer, isn't it? 2, and is 3 on the inside of the orange triangle? It's not in the corner. 2 is in the corner, 4 is in the corner, and 6. So which of those are not the ones right next to 7? 1, 4, which we already listed, and 2, because 2 is on the corner of that orange triangle. All right, we're going to do one more with this example. We're going to do angles greater than the measure of angle 6. Greater than means we're going to start on the inside and we're going to look for outsides. Less than means we have an outside and we're going to look for insides. Kind of goofy. This is the goofiest thing you will learn this year. Don't ask me where you're going to need this in real life. I don't know. I can tell you almost everything else about geometry when we're going to need to use it. This is madness.
If you haven't realized that, that's not really hate chapter 5.
I really hate chapter 5. It's the worst. Alright, so angle 6 is right here. And we're looking at angle 6 being on the inside of a triangle. Which triangle is angle 6 on the inside of? LKM. That's one of the triangles it's on the inside of. Now what I'm looking for is if I extend any of those sides. So if I extend this side, do I know that outside angle? Nope. What if I extend this side? No, we know angle 8 is a part of it, but we don't know the whole angle. Okay, what about this angle? Do I know that angle if I extend it? Yeah, that's angle 3. So 6 is on the inside, and of that triangle, 3 is on the outside because I extend that side. So we know angle 3 is going to be one of them. Are there any other angles by this side? No. Okay. Are there any other triangles where 6 is on the inside corner? What other triangle could I draw with 6 being in the corner? I could go to K, J, and then L. And that big triangle, what 2 angles are on the outside? 7 and 8. Which one can I say for sure is bigger than 6? 8. Based on appearances, it looks like 7 is bigger than 6. But we don't know that for sure. The picture could just be really bad. All right, we have one more theorem. And this one makes a lot more sense than this one. I like this next theorem. It's probably my favorite theorem of chapter 5. I'm going to go to the next page. All right, angle-side relationship theorem. Angle-side relationship theorem. All right, and what this says is if side AB of a triangle is bigger than side BC. Okay, so if I know that AB is bigger than BC, what that's going to tell me, or vice versa, depending on what information I'm given, is the angle opposites of AB is bigger than the angle opposite of BC. When we talk about opposite, that means like traveling across the triangle. Okay, so if we know one of these things, if we know how to compare angles, then we know how to compare the sides. Or vice versa. If we know how to compare the sides, we can compare the angles. So in our drawing of our triangle, what angle is across from AB, this side, AB? Which angle, if I travel through the triangle, which angle would I end up at? C. And what would be across from BC? A. Yep. So I'm going through the triangle. Alright, we're going to do 2 really quick examples of this. And then you get the rest of the time to work. Okay, now this might sound complicated, but it's a lot easier than it really is. Okay, so if I draw a triangle ABC, and I have those side lengths 11, 15, and 13. Can I compare those numbers? 11, 13, and 15. Can I put them in order? Yeah. Let's go in order of least to greatest. What is my least number? 11. And that's less than 13. And 13 is less than 15. So far, so good? Okay. Now let's name those sides. Which side is 11? AC is less than, what side is 13? CB, which is less than, what's the side of 15? AB. So because we know those sides, we can now compare the angles. And we're going to always travel across. So if I start with AC, AC is 11. That's this side. If I travel through the triangle, what's the angle opposite of the side? B. So I know angle B is the smallest angle. Okay? That's going to be less than what's across from CB. If I look at CB, what's across from CB? A. And then lastly, we have AB. And what's the side across from AB? C. So which one is the biggest angle of the 3 angles? C. Which one is the smallest? B. In the middle? A. And that's it. I said we were going to do 2 examples, but I lied. We're just going to leave it at that.